Next up, we have Marina Polishchuk, a research software engineer at Microsoft Research. She's passionate about systematic testing complex software as well as teaching engineering best practices. Over the past 15 years, she's created testing tools for the Visual C++ compiler and the SQL Server database engine. She's currently working at Microsoft Research on the problem of how to find security and reliability bugs in cloud services through fuzzing their REST APIs. Before Microsoft, Marina got her master in computer science from the University of Wisconsin-Madison and her bachelor in math and computer science from the University of Michigan. So, Marina, great to have you here. I'm really looking to your talk on stateful REST API fuzzing. So, the mic is yours.
Great to be here. Thanks, Matthew. Can you hear me okay?
I can hear you fine and I can see your slides. Everything looks good.
Perfect. So, my name is Marina. I'm from Microsoft Research, and today I'm going to talk about a tool that we've built based on some research we've done on REST API fuzzing. So this talk is going to be all about APIs. All right, so how important is it to fuzz REST APIs? Well, as all of you know, web APIs are everywhere right now, and in particular, there's been huge growth in the past few years of public APIs that's officially tracked, but then also microservices architectures have gotten very popular. So there are lots of private APIs, and there's an increased attack surface on all of those fronts. Moreover, all of these services are rapidly evolving. So the matrix of different versions constantly being added, new features, as well as things have to be patched in production occasionally very quickly. This all, again, kind of increases the risk that something will go wrong, and you need testing to keep up with that rapid pace of development and deployment. So the question we ask ourselves is how secure and reliable are the APIs, and how can fuzzing help? So this is going to be the outline of my talk. I'll motivate why do stateful REST API fuzzing? What does that mean? How can that help you get good results with fuzzing? I'll talk a bit about RESTler, which is a tool that automates stateful REST API fuzzing. I'll talk most of the time about the type of bugs that RESTler can find, a bit about CI/CD, and some future work we have planned. So RESTler actually came about as a project mainly motivated by Microsoft internal feedback on having applied some techniques and having some issues that they wanted us to take a look at. So we started researching this problem in 2017. And some of the things that we saw that people were trying is, one is just either manually or loading up an API specification and fuzzing each request in isolation. And so if you do that, just automating that will have pretty low coverage. So you need a human in the loop to really guide the fuzzer and make sure that it's covering what you intended to. There are also many ways that you can do traffic capture and replay with fuzzing, and this is pretty standard. But of course, the coverage is going to depend on what your traffic is, whether it's from live traffic or from your unit tests. So again, you really need quite an investment there. And then for high-value targets, people, of course, were manually writing fuzzers. So all of these solutions, they can work very well, but the problem is they were not really scaling to large, rapidly evolving REST APIs, such as, for example, for Azure services. And also, there were some important bugs that these missed, and we'll go into it in the rest of the talk. So here's an example bug. So if you look at this for just a few seconds, see if you can spot what the bug is here. So there's a client. It's first creating a resource of type CM, and it's named X. It has a value, so red here indicates that it's invalid, so it's actually a fuzzed data value. And it's creating it in some region, US West. And there's a 500 internal server error. And that's already kind of a bug indication that something went wrong, but let's see how much further we can take this. So you get all these resources of type CM, and you don't have any. Well, okay, I got an error. Everything seems fine. But then what if you try to create that same resource now with a valid value and in a different region? I should be able to create that resource, right? Well, in this case, we weren't able to create the resource and we got a conflict. So what happened after some manual investigation, we found that X is now a zombie resource, and moreover, it wasn't counted against the user's quota. So an attacker can just keep creating these resources very quickly with different names. And potentially there could be a DOS here, both in terms of an actual resource on the backend that's not getting cleaned up, or in some cases, like just the domain of names can be finite and not that large, and you can prevent users from creating like any resources of type CM. So what you should take away from this is that to find this bug, you need both invalid inputs, valid inputs, and this carefully crafted kind of sequence of requests. And this is precisely what we were trying to target with RESTler and with our fuzzing algorithm that we've developed. So RESTler is stateful. So what does that mean? All the tests in RESTler are sequences of requests. And we only fuzz a request if all of the prerequisite resources can be created. So we found that this really provides much deeper coverage than if you try all the requests, regardless of whether prerequisites are available. And the fuzzing algorithm also works hard to avoid redundant testing. So I won't have a lot of time to go into that, but you can refer to some of the RESTler papers for the details. It's automatic. So here today we require an Swagger Open API specification. We found that internally at Microsoft, as well as talking to our users since we've open sourced the tool, a lot of the large kind of public cloud services do use Open API specifications because they use those to generate client SDKs. So this is something that developers kind of already maintain as part of their existing workflow. And this is great because when we plug into that workflow, we can both find bugs in those specifications as well as actually get a pretty good, reliable artifact for fuzzing. And what RESTler can do today is it can provide, using those specifications, good coverage out of the box if the specification has enough details. And RESTler is also extensible. So in addition to catching things like 500 errors, it allows you to write your own security checkers and plug into the fuzzing loop. So how does it work? It takes an Open API specification, and the first step that it executes is it compiles it. It infers each request type, which is basically taking the full schema and figuring out what are the inputs and the outputs of that, and then identifying producer-consumer dependencies. So this means one request produces a resource, what other requests actually need that resource as an input. And it also has code to parse responses. In the second step, the test engine, which is actually what's generating and executing the tests, it takes the grammar, it runs the service, and it executes requests against the service, and it analyzes test results. And one thing that it does to prune the state space is it has a feedback loop to learn from past service responses and avoid duplicates. So if you've already tested, for example, the sequence A/B, and you got both 400 error codes for A and B, you're not going to try A and B in a certain context until maybe you've moved on and maybe you can find a bug that you couldn't earlier. And it's doing a systematic state space search. So it's really is trying to find all the sequences and all the combinations of parameters while being as efficient as possible. Here's an example. So you have a simple blog service here, and the compiler will produce a grammar. This is an abbreviated form of the grammar. If you're interested, I encourage you to go on GitHub and try out like the demo, which is basically this service here, and look at the grammar more closely. But it basically describes the schema of the request, parsing out of the response what it needs, and the dependencies, which is the ID here. So then the RESTler test engine takes that grammar, and what you see in the output, this is just a standard kind of HTTP request that it's sending. It's not doing anything more fancy than that. So in particular, RESTler is a black box fuzzer, so it doesn't expect any kind of instrumentation to be available. All it's using for feedback is the responses. Here's a typical fuzzing session. So there are a few interesting things here. One is look how many positive status codes there are. So this is, again, kind of what differentiates RESTler as a fuzzer, is it's really trying to first execute kind of a positive scenario, really get deep inside the application, and then do fuzzing. And another thing that's notable about the fuzzing session is that each time you go deeper into the search, which means you increase the sequence length, we actually found for this blog application, which we were able to instrument, that coverage did increase with each sequence length up to length 3. This is a very simple service. So the sequences here, what this means is the first sequence is just trying each request in isolation, but only if it has all the prerequisites. And then in this sequence of length 2, you're able to now get a little bit further because you've created a blog post and now you're able to read it and to delete it, and likewise for sequence length 3. So what are the type of bugs that RESTler can find? You already saw one earlier that I presented. Our first case study was GitLab. So GitLab is a pretty complex service, about 300 request types. And we found 28 new bugs. And this was just looking for 500 internal server error codes. This was our initial case study. And an example of bug is you create a project, you create a repo with a proper valid commit, and then you delete the repo file with an empty commit message. So, we expected that to all be valid, but instead we got a 500 internal server error. And all of these bugs have been fixed. You can read more about it in this paper, Stateful REST API Fuzzing from ICSI 2019. A more recent study we did was on a few Azure services. So I'll just talk about one here in the interest of time, Azure DNS. And here we actually developed a specific new algorithm for JSON payload fuzzing that also has a feedback loop, and in particular, it dynamically learns and augments the set of possible inputs using past responses. So for those of you who've worked with APIs a lot, you know that sometimes you can create a resource with just one parameter, and the schema has like 1,000 parameters. But then what the data that you actually get back is you may get all 1,000 of those parameters initialized with whatever the defaults are in the system. And so this can be very interesting to then fuzz those values. So in the DNS service, it has 13 request types. Many of them, however, have a very large schema. So this 65 schema elements and like lots of enum values. So the state space is actually pretty large. And here we used error code and message as a signal of coverage. So this also has some coverage guided kind of element in this algorithm. And we actually found new 500 server errors in all of these, all but one of these requests. And the last one only had 2 schema elements, so it wasn't very interesting. And after deduping everything, there were 7 new bugs filed. Again, you can read in more detail about the bugs in this paper from FSC 2020. All right, so to talk a bit more about classes of bugs found by RESTler. So the interesting thing is if you use the tool, like any tool, sometimes you're going to find these bugs automatically. Sometimes when you're actually investigating, hey, what is wrong here? I'm trying something, it's not working. Is the tool not working? After some more investigation, you can possibly find some more bugs in the service. And then we actually had a few bugs that were found by service alerts by running RESTler, which are bugs that RESTler isn't designed to try to find, but in the course of it running, it kind of triggered something going wrong in the service. And I'll talk a bit about those. So one use case for RESTler is actually validating the API specification. We make use of examples to try to help with the initial coverage, initial positive coverage. And if the specification is either under-documented or inconsistent, RESTler basically won't work well out of the box. And during that investigation, you'll find either you can work around that by using RESTler, or you can actually fix those specifications. Of course, one of the biggest classes of bugs is input validation. And today, the main test oracle for that is getting 500 server errors instead of an expected 400. So we found a few bugs in authentication. We have some specific checkers for testing whether you can access another user's resources that you shouldn't. But also, you can just try RESTler with an invalid token across a large API And if it runs and you see in the course of it some 200s, that's a sign that something might be going wrong. You might have an unauthenticated API bug. And then we also had one pretty interesting bug where we ran RESTler, and it was fine in kind of its quick fuzzing mode that it has. And then when we went to full fuzzing, it kept crashing. It kept just disconnecting from the service at a particular point. So we're like, why is this happening? And it turned out that there was actually a bug that turned out to be a design bug in the API where a particular value was corrupting the authentication code path and was just causing the service to be invalid. So these bugs do happen. These kind of more severe bugs. Similarly, like resource exhaustion is one that we've seen where just by running RESTler, it's not able to detect those bugs because they're on the back end and it's completely black box, but it can cause issues that are caught by service alerts and service incidents. And then you already saw some examples of resource management issues in the first bug that I showed. Similarly, data leaks. Today, RESTler doesn't have kind of an automated way for you to try to find data leaks, but just by looking at the logs, you can discover them. So we found one that I wanted to call out here. And the really encouraging thing is we've actually been tracking the bugs that we reported both internally and a few in the open source in the GitLab project, and all of these bugs are being fixed. So even when they're not necessarily security critical, people see the potential for them to cause issues later down the line, or sometimes they're just user experience bugs and they're very willing to fix them. And of course, in terms of like scenarios for where to run RESTler, careful when running it in production because it has some of these severe bugs that can happen. Instead, think about if you're able to run REST API fuzzing during development, or CI/CD regression fuzzing is becoming very popular for kind of traditional binary fuzzing. But of course, a big problem with putting things in CI/CD is the time and the complexity of having a reliable test environment in CI/CD that isn't going to be breaking your builds all the time. So one kind of happy medium that we've seen some people adopt is doing RESTler testing during deployment validation. So where you already have some test environment that is good enough for you to do other integration testing, maybe also running some fuzzing would be safe there. RESTler does try to clean up after itself, as much as it's able to based on the knowledge that it has. And then also, if you're looking to bug hunt for specific classes of bugs, you can either use the existing checkers that it has or tweak them a bit if you're looking for some kind of specific authentication code path that isn't covered by the out-of-the-box checker. The code is out there, so you can definitely extend it pretty easily. So to talk a bit about CI/CD, so a big element of CI/CD is scale. And you may already have your own CI/CD system at your company. We've developed one specifically for REST API fuzzing. So I'll talk a little bit about that. This is a tool called Raft. And Raft is a self-hosted REST API fuzzing as a service platform. So what it does for you is it can run a variety of tools already, including RESTler and Zap, and it's easy to onboard new tools. And it basically spins up a bunch of Docker containers and can trigger off of your build and give you bug notifications back that you can use in your day-to-day CI/CD. And for more details, you can see this link. So here's kind of roughly the workflow. So you push code, and when you start a Raft job, it basically the configuration is something that you already have checked into your repo, so it doesn't require a lot of kind of reconfiguring based on the changes in your API. You just still need to provide that open API specification. And through working with various teams at Microsoft, we've added some features that you may care about, like secret management and VNet support. And also you can use it in your local testing. One scenario that you may want to run is it's good at launching a bunch of different tools in parallel. So if you want to kind of stress the system a bit more, you can do that with Raft. So in terms of challenges and future work, so one thing we are really driving toward is better coverage out of the box. So if your service is pretty simple, maybe the Open API spec has enough detail to get 100% coverage. Otherwise, some initial configuration is required. So today, we use examples that are provided with the specification. We want to improve how we handle that. There's just implementation limitations, but also being able to mine a lot more valid values from examples, as well as search for valid data payloads using those values in the algorithm to try to get the initial coverage to be higher. Likewise, this algorithm to infer producer-consumer dependencies, so understanding what resources a particular API produces that then are required as inputs to other APIs. We want to improve those detections. We're working on supporting CI/CD as well as regression fuzzing. And finally, a few people in the community have reached out on their scenarios for security checkers that we didn't cover. So we're really excited to hear more about this. This is definitely an area where we can do a lot more. And so if you're interested, or you've already implemented a new checker and you would like to integrate it or just share your results, please talk to us on GitHub. We're looking closely at that right now. All right, and this concludes my talk. So APIs are everywhere. They're a rapidly growing attack surface, and hopefully I've convinced you that REST API fuzzing is important, and stateful REST API fuzzing can help you get deeper API coverage. But as is evident, thoroughly fuzzing services with a large or complex API is a very hard problem. Automated tools like RESTler can help, and there's definitely more improvements that are possible. So in conclusion, thanks for coming to my talk, and please try out RESTler and Raft and give us your feedback. Thanks.
Thank you, Marina, so much for your talk. And I can only echo that call. Please do go out and try these tools. Your apps will be better for it. So we've got lots of questions coming in. I hope we can squeeze them all in. I'll bundle a couple of them around coverage. You were talking about, on the second to last slide, that you wanted to improve coverage out of the box. Could you maybe talk a little bit more about how you're planning to do that, and if code coverage as in a non-black box approach is something on your roadmap?
Yeah, so today, kind of the immediate next step is being able to better take advantage of example payloads, such as from traffic, such as from the OpenAPI specification provided to the user. So as an example, RESTler today takes all of the example values that it has and kind of uses it as a set. So it just has, for this parameter, there's 5 values, this other parameter, there are 10 values. It doesn't actually treat those as a holistic, like this was a full request that was sent. So that improvement is probably the first one that we would do. Further down the line, also, the algorithm today, again, doesn't have, it kind of explores the space of all the inputs using a uniform approach. It doesn't have something specific to try to raise coverage versus to try to find bugs. And then as far as the incorporating instrumentation, so this is a scenario we've talked about for a long time. Some of the services that we've been dealing with, this would be pretty kind of difficult to determine, like, what do you instrument, because the system is very large. But I think it's definitely something that could be done in terms of incorporating some signal like that into RESTler. So talk to us on GitHub if you have ideas, but I think that one is probably a bit further out. We're not going to immediately focus on that, like, in the next few months.
Yeah, I understand that. So actually, there's a good follow-up question to that. Are you actually using RESTler against Microsoft products like Office 365 or API, Azure APIs and stuff like that?
Yeah, so it's been applied, and I think it was on the slide, but I forgot to mention this. So it's been applied to various products in Office 365, Azure, and Bing over the years, and I would say like there's a variety of levels of maturity where people are applying. Some of it is just like engineers trying it out and finding bugs. Some of it is, people are setting up to run it in CI/CD. So yes, it's been applied, and there's actually quite a bit of detail in the two papers that I mentioned. One is from ICST 2020, and one is this recent FSC paper, FSC 2020, where you can read more about some of those case studies.
Okay, excellent. And then we have one maybe more technical question. I hope that you'll be able to locate what exactly they're asking. The question is from media asking, how do you construct the tree? Is it based on REST dependency from the Open API? I think that was from near the beginning of your talk.
Yes, so that's correct. It's based on the dependencies plus trying all the combinations of the request types. So for example, if you have request types A, B, and C, you're actually going to try AA, AB, BA, etc. But only if they don't have any dependencies. If A is required to be run before B, then you're not going to have BA. So hopefully that's like a very simple explanation. Our first paper has a lot more on different algorithms that we've compared to determine which one works best.
Do you have a web page or a social media account where I can point people where they can find your papers?
They're actually all linked off of our GitHub project page.
Okay, excellent. So folk who want more technical detail, go to the GitHub page. Reading papers is really interesting. Okay. Then one more question which came in is, how do you how do you evaluate RESTler internally? So how do you measure when you're whether you're improving things or not?
Okay, great. So there's two main metrics that we use, and then we have metrics for specific features of RESTler. So the two main metrics are how good is the coverage for the APIs out of the box. So there's actually a special mode of RESTler called test mode that all it's doing is it's trying to quickly run the minimum number of tests to exercise the entire API and see what is the positive coverage. So this is much more like just functional testing of the API. So we measure that by, we have a bunch of services where we know we've had trouble in the past, and we essentially have a coverage number that we collect after we do major features, and we see whether it's improved or not. And then the other is effectiveness, by the number and type of bugs we find. So this is something we look at where sometimes RESTler finds these bugs, we report them, and then we can't always tell how severe the bug is. So often, we look for feedback. Also, we look for feedback of, hey, this bug wasn't flagged by RESTler, but when I looked in the logs, I saw that this bug was happening. Will you incorporate it so it's actually able to report it?
Okay, thank you so much. Okay, sadly, we are out of time, so let me thank you again for the wonderful talk. And that was a great insight into how RESTler works, and I'm looking forward to see what you do with it in the future.